All right, for this is the last video lesson of for 1.5 of all the graphing before we take the quiz on all the graphing. Now we're going to graph what's called piecewise functions. These graphs look really, really weird. This is where you're going to graph at least two equations on the same coordinate plane, but their domains are restricted. And what do I mean by domains restricted? I mean this. This is what the domains are. So like for this first example, we're graphing two lines. One's 2x plus 3, but I'm only graphing it where the domain is x is less than or equal to 1. Okay, and then the domain is restricted for the second one, the negative x plus 4. So what I'm going to do first, I'm going to graph the whole line for each of them. And then I'm going to erase the parts that aren't defined in that domain. Okay, the first one, the 2x plus 3. Well, I know this right away. I'm going to put this graph in green here and kind of make side notes here. I know this line goes up left to right because the slope is 2. But it's saying we're only going to graph it as x is less than or equal to 1. So, you know what? Let's just do this. Let's graph the whole thing first. I know my y-intercept here is 3. It's already in slope-intercept form. So I go up at 3. Okay, then from there, right, if I use my slope, no, that's not what I want. If I use my slope, there it is. This is pretty cool. I haven't used this one before. Man, I'm such a dork. All right, but whatever. I go up 2, and then I go to the right one, and then that's the next point. So I plot that up 2 to the right one, and there we have it. That's all you need is 2 points. I'm going to connect it. Now, don't do this all right now, because eventually, if you are, make sure you have a pencil. Now, that's the whole line, 2x plus 3. Now, I'm only graphing a piece of it. I'm only graphing it where it's defined here, x is less than or equal to 1. So I go down here where x is 1. This is where x is 1. And where x is 1, I have this point right here that I'm highlighting, I'm making bigger. And it's equal to it, so I'm going to leave it as closed. Now, I'm only graphing where x is less than or equal to 1. So this is where I'm going to keep going this way. I'm only going to look at this portion of the graph. So I'm going to erase everything to the right of x equals 1. So I'm going to erase this. And that's the graph. Notice how this graph, the arrow goes to the left. Well, the reason is because this inequality symbol goes to the left. So that can kind of help you out. All right, let's get the second graph. Let's do that in red. Okay, let's just erase everything else that we did. Okay, I don't know why it's not erasing it. All right, whatever. Let's do this in red. Okay, when I do this in red, I'm going to make these notes up here. Negative x plus 4, the slope's negative. This line's going to look like this now. But see how this is going to the right? So we're only going to get the arrow that goes to the right, which is this part. This part is what we're going to wind up erasing, so I'll put an X over it. We're going to wind up getting rid of that. So let's graph the whole thing first. My y-intercept here is at 4. So 1, 2, 3, 4, right up here. And then if I use the slope, it's negative 1. So I can go down 1 to the right 1. Okay, and then I have 2 points. I connect it. This is my whole line. Now, first thing I'm going to do here, let's go to where x is 1. Again, this is where x is 1 right here. I'm just going to go over it in red. Now, see how it's not underlined with the inequality symbol? So I'm going to make this an open circle. So I'm just going to erase that. And let's make this an open circle right here. And then, since it's greater than 1, I'm going to get rid of, I'm going to get rid of this right here. And this is what our graph should look like. Get rid of that piece there. All right. So the graph looks really weird. We only graph certain pieces of each function. But the main thing to remember here is, see how if you go left to right, there's no overlap. The graphs don't overlap because these numbers, they're always going to be the same there. All right. Okay, let's do the next one. Okay, we do the next one. All right, let's look at, well, first we have this x squared minus 1. Let's put the little notes right here. This is going to be a parabola that goes up. Now these, if you graph that on your own, like, you know how to graph these. They're very easy. We've done a lot more transformations that are a lot more difficult. You're not going to see really difficult transformations, but instead of having one graph, you're going to have a couple. So x squared minus 1, this is going to shift down 1. So it's just going to go down 1 unit. So I'm going to graph the whole thing. So the vertex is going to be here at 0, negative 1. That's at 0, negative 2. Okay, so we go down to 0, negative 1. And then I know since this is 1x squared, when I go to the right one, I go up 1. So I'm going to have a point there. I go to the left one, I'm going to go up 1, so I'm going to have a point there. So I'm going to plot those points right here and right here. And here's our graph. Now the one thing I am going to do, I noticed that this is called the boundary point. I noticed the boundary point is at x equals 2. So I also want to put in what the y value is when I plug in x equals 2. If I plug in x equals 2 for this, I get 2 squared minus 1, which is 4 minus 1, which is 3. So I'm going to go up at 2, 3. So 1, 2, and here it should be about right here. So let's make this a little bit more exact. All right, so that's the whole graph of the parabola. All right. Now this, it's pointing to the right, so I'm going to graph the portion of the graph that's going to the right. So let's see here at 0, or excuse me, at 2, which is the boundary point, at x equals 2. I'm only graphing where it's greater than 2. So this is where we're at 1. Oh, did not do this right. It's a little bit difficult doing it here. Let me erase this. I apologize. You guys have to put up with me. Let's see here. You're at 2, 3. So 1, 2. So this is where it is. Okay. All right. So now what I'm going to do is I'm going to erase everything to the left of x equals 2, which is really almost all of the parabola. So I get rid of this. Okay. For whatever reason, I can't get rid of that dot, but just disregard that dot right there. So I only get that portion of the graph. Now the other thing right here, I'm going to get rid of that dot. This is not underlined. So this is where I have to have an open circle. So that's it. That's your only part that you get. Okay, let's do the next one. Let's do the next one in green. Okay, I do the next one in green. When I do the next one in green, I have x cubed. So if I have x cubed, that's just my basic S-curve. Okay. So I know this. Let's make the notes here. I know this just looks like this. All right, where the middle part is right at the origin. So let's graph this. Middle part's right at the origin right here. Can disregard that red dot right below. And when we put 2 cubed into this, let's get our boundary point. That equals 8. So at 2, let's see, we got 1, 2, 3, 4, 5, 6, 7. It's off the chart just a little bit. It's right here at 2, 8. And this is what the graph looks like here. Now that's actually it. I'm not going to keep going because see how this just goes to the left? So all these values here, 2, 1, negative 1, all these x values are less than 2. So I'm just going to have this going to the left. So that's what your graph looks like. All right? So they are a little bit weird. The ending result looks very, very difficult. But I think probably the best approach is you're very good at graphing all these with all the transformations. Just graph the whole thing. Have an eraser with you and just erase the pieces that you don't need. So right now, I want you to do 3. Now 3 is a little challenging. Let's go to number 3. Okay, 3, you can see this right here. Now you have 3 equations. So see if you can get this, okay? It's going to take a little bit of time, but just to kind of get you started, this x plus 2, I know that's a line that goes up left to right. Now, see how here it's pointing to the left? So you're going to wind up only getting the graph. It's going to look something like that. The next one, the x squared minus 2, again, that's a parabola that goes up. And the vertex is going to be down at 0, negative 2. And then the last one, a lot of times this confuses students right here. Let's not do that. This is like saying y equals 2. All right, this last one, that's just a horizontal line at y equals 2. So there's your little hint there. You have two lines and you have a parabola. See if you can figure it out. Get the graphs. See where you have open circles. See where you have closed circles. Good luck. We'll go over this one tomorrow.